Today, we will be discussing about the chemical reactions involving differential equations. As you can see here, VO is equal to volume when time is equal to 0. And QO is equal to the amount of solute when time is equal to 0. The concentration, or the C, is equal to the amount of solute all over the volume at T is equal to 0 plus the quantity R1 minus R2 times the total time. R1 is equal to the first rate while R2 is equal to the second rate. And for the next equation, dq is equal to dt. It is equal to the first rate times the second concentration minus the quantity of the second rate and multiplied with the second concentration. And finally, for the derivative of the amount of solute with respect to time, the equation is the first rate times the first concentration minus the second rate times the quantity amount of solute over VO, which is the volume at T is equal to 0 plus R1 minus R2 times the quantity of T. Then, as you can see here, Q is equal to C because they just substituted the C here to get this equation. That's it. A 350 capacity tank holds 200 gallons of brine solution with 30 pounds of salt. A concentration of 2 pounds per gallon is pumped in a rate of 3 gallons per minute. The concentration leaving the tank is pumped out at a rate of 2 gallons per minute. How much salt is in the tank after 12 minutes? When does the tank overflow? How much salt is in the tank after 30 minutes?
So here are givens. The first rate, 3 gallons per minute. The second rate, 2 gallons per minute. And the first concentration, 2 pounds per gallon. And the initial volume, 200 gallons. And the initial amount of solute, 30 pounds.
Go.
So the required quantities are the amount of solute at time equal to 12, the time it takes for the solution to overflow, and the amount of solute at T equals 30. So we will just substitute the values in our equation. So the first rate, R1 equals 3. Concentration number 1 equal to 2 minus R2, which is 2, and C2, which is just equal to Q over 200 plus 3 minus 2 times T. So we will get this equation. And since this is a linear differential equation, we will use the integrating factor, which is just equal to e raised to the integral of P. So we'll end up with this. And we'll just multiply it with Q. IF times Q equals the integral of Q and IF dt. So then, we'll get this equation, and our final solution to the differential equation is 200 plus t squared times q equals 2 times 200 plus t cubed plus c.
First, we're gonna use this equation that we got from the previous solution. So we're gonna substitute t equals to 0 and the initial amount, which is 30. We're going to substitute here in this equation in order to get the constant, which is negative 14,800,000. Then we're going to put this equation in the previous equation, which is this, which will result to 200 plus t quantity squared times q is equals to 200 plus t cubed minus 14,800,000. Then since we're finding for the q at times 12, we're gonna substitute for the t. We're gonna replace t with 12. Then we're gonna solve for the q, which is the amount of solute at time equals to 12. Then plug in the equations. So it's going to be 200 plus 12 squared is equals to 2 times 200 plus 12 cubed minus 14,800,000. Then algebraically, you're gonna isolate Q in order to solve for the Q at times equals to 12. Then the final answer would be 94.7 pounds.
After 30 minutes, Q30 is unknown. So, to find the Q30, we need to substitute T equals 30 to the main equation. 200 plus 30 squared times Q30 equals to quantity 200 plus 30 cubed minus 14,800,000. Isolating Q30, we come up with Q30 equals 182.2 pounds.
For the last part, we will solve for the T overflow. So when does the tank start to overflow? To solve this, we will use the equation V, which is the capacity of the tank, equal to the VO, which is the amount of volume when time is equal to 0, plus the quantity R1 minus R2 times T. So to solve this, this is simple. We will just substitute 350, the given 350 to V. And then we will substitute VO, the given VO, which is 200, and add it to the quantity T minus 2, where we substituted the 3 gallons per minute, subtracted to the R2, which is 2 gallons per minute, times the quantity T. So using algebra, we'll just add and then isolate T, so we can get it. After that, we can get T is equal to 150 minutes. That's it.
I've been walking through all these places that I cannot stand. I guess it's just my history talking. Now I'm refusing to supply your